Okay, good evening, everybody. Behind me, you see a fast-forward plate Twitter stream of cases in Brazil, actually. And the question is, of course, what could you do with such a stream? What would the value be of having such a Twitter stream? And the first thing is, of course, that it's time-stamped and it's not aggregated over a month or something like that. Another thing that is very good about the stream is that it has an arbitrary location, and you can define regions of arbitrary shapes that do not keep themselves to the borders of a country, for example. And also because the people that are actually having dengue can actually take part in reporting their cases themselves. For example, in regions like Africa, where they might be underreported, we could actually make it a little bit more reported by using Twitter. Now, the next slide, please. All right, so we are TeamStream, and we tried to develop a nearly real-time surveillance system. And I will present myself. So I'm Hannah. I study physics and artificial intelligence. This is Cyprian. He is a programmer and a junior data scientist. We have Laurent. Laurent. Sorry, I'm really nervous. This is Laurent. He's also a programmer. And then we have a biologist. We have Sabrina here in the front. And then we actually should thank Glenn from the Lucia team for doing the visualization, which comes later on. And the guys from the Cube. I don't know where they are. For providing us some more Twitter data. Thank you very much. So you can see that we're not really mixing experts, but we're a very gender-balanced team, so that maybe that's also something. Okay, so the next slide, please. So yeah, there was a team, and so I already explained the benefits of the real-time monitoring system. So what did we do to actually use the system? We gathered social media tweets from the whole of Latin America. And why we choose Latin America? Because we had to actually filter them on personal experiences. So in Latin America, there's only 2 languages, so it made it a little bit easier for us because we do not speak fluently Chinese and stuff like that. So we try to filter them based on a random forest, and then we retained personal experiences. So for example, damn flies, I got dengue. Why flies? We don't know, but anyway. So we got then a data set with of tweets with a timestamp and the location. And we got from our ID, we got from a paper that did that for Brazil, and that actually showed that if you do a quite good classification of the tweets, that you get a correlation of the outcome clusters of around 95% with the clusters from official data. But of course, you need to have official data to do that. And in our case, it was a little bit difficult to get that, but we tried to have a rough estimate. And we had the 3 first weeks of January of official data for Brazil, which is the background colors, and then the things we got from the tweets, which are based on the color. The colors are related to how much weight, how much tweets are related to that point. So the next slide, please. Okay, no, yeah. Yeah, before you start the demo, maybe you should explain a little bit more about the stream clustering algorithm. So it's a stream clustering algorithm. It's called dstream. And every point that comes in is actually assigned a certain density, and that density decays over time. So it's a density-based clustering, and so it's a sum of points, and those points decay over time. So you can have the newest tweets add more value to your clusters, and the oldest one decays. So you can actually see the evolution of the clusters over time. And this is the visualization made by the Lucid guys. And so you can see the tweets popping up as the small points, and then the centers of our clusters and the points that are assigned to them. And yeah, that's basically it. So the advantage of the clustering algorithm is also that you can define arbitrary regions, and that you don't have to say beforehand how many clusters you want to obtain. Okay, and then we had a lot of problems with gathering the Twitter data because that's an API, and sometimes you get blocked for some very unknown reasons. So that was quite difficult, but it was also quite difficult to assess the model because we didn't have really official data to compare against. So there was really difficult to do that. So we should definitely try to, if this model is used further, should improve upon that. And then the future things that we could do with that is, for example, setting up a web application and trying to encourage people to mention on Twitter that they have dengue in all kinds of regions, and try to make it, to make people report Twitter, and also use data from, for example, Break Dengue or Google, not Google Flu Trends, well, Google Dengue Trends, or whatever is out there to improve the model. So thank you very much.